The KINGSINE KFA320 protection relay tester features a compact interior design, similar in size to an iPad, and is powered by replaceable batteries. Weighing only 3.8 kilograms, it offers a 10.1-inch touchscreen for user operation. Additionally, the KINGSINE KFA320 supports IEC 61850SV and GOOSE, LPIT simulation, energy meter testing, low-level output, and transducer calibration. Its compact design enhances engineers' work efficiency while meeting complex testing requirements. Let's move on to the top panel. Here, we'll find 4 pairs of binary output channels, 4 pairs of binary input channels, and 4 voltage output channels, each supporting up to 300 volts. For current output, it offers 6 high-power channels, each rated for 20 amps, with a maximum parallel output of 60 amps when extra capacity is needed. Let's look at the top right corner. Here we'll find 1 pair of power pulse inputs, specially designed for precise energy meter calibration. At the bottom, we'll find 4 pairs of LC optical ports that can be configured as either SV transceivers or for GOOSE publish and subscribe functionality. Here we have 4 FT3 interfaces, with 2 dedicated for transmission and 2 for reception. These flexible ports can be configured to operate either as FT3 message transceivers or as I or IGB interfaces. These indicators display the status of both fiber ports and FT3 interface. The console port is reserved for debugging and troubleshooting only. Next to it is an HDMI expansion port, designed for future upgrades and additional functionality. Here's the RJ45 port for Ethernet connection, simply plug in a network cable to enable PC control of the device. This USB port handles SCD file imports, waveform transfers, test configurations and report exports, and software upgrades etc. Here we have the GPS interface, primarily used for precise timing synchronization. To its right, we'll notice the GPS status indicator light. Meanwhile, the KFA320 also supports Wi-Fi functionality. Now let's look at the right side panel. In the bottom left corner, we'll find the auxiliary DC port. This port connects to external expansion modules, providing a stable 0 to 350 volts DC output. Here's the Type-C charging port for powering the tester. The indicator light on the right shows the charging status. Here's the grounding terminal. Always connect this first for safety before running any tests. And on the right is the power switch. Now let's take a look at the KFA320 software interface. The basic mode includes 6 commonly used test modules. Let's start with the AC test module. This tool lets us adjust voltage, current, and frequency, either manually or automatically. We can also customize fault parameters, compensation coefficients, and switching logic, including trigger conditions and fault states. Plus, during tests, the right panel shows live vector diagrams and instant results for easy monitoring. The DC test module offers similar functionality to AC testing, but specifically controls DC voltage and current outputs and variables. With the state sequence feature, we can program multiple test states, perfect for measuring protection devices' action times, return time, and repeated auto-reclosure processes. The harmonic testing module allows users to set the base wave and 6 harmonic components. After configuration, all groups output simultaneously, and the waveform preview shows harmonic content. Results are listed with action values and times. The recurrent function allows the device to replay the Comtrade fault waveforms repeatedly. The synchronization testing module simulates generator-to-grid synchronization and performs sync checks. The advanced interface provides access to 10 functional modules supporting complex testing requirements. The first test module is differential. This module simulates internal faults to test startup current, quick break current, proportional braking, and harmonic braking. Users can freely configure parameters and view corresponding curves. Distance module tests distance protection relays by verifying impedance zone ranges and trip times defined in impedance characteristics. It allows adding multiples and performing segmented tests. Distance CM. Fundamental frequency variation protection achieves rapid and reliable short-circuit detection by extracting fault components, making it suitable for protecting critical equipment such as transmission lines and generators. Its core lies in the accurate calculation of fault components and the sudden change startup criterion, combined with adaptive adjustment strategies, which can effectively enhance the safety and stability of power systems. The overcurrent segment module is specially designed to verify overcurrent protection settings, checking both action values and times. Simply set the parameters, then with one click we can add fault types, overcurrent section values, and adjust test multiples. The Overcurrent Zero module specializes in zero-sequence protection testing, verifying both action value and time. Easily configure different fault types, set zero-sequence section values, and adjust test multiples with just a few clicks. Overcurrent VZ Lock. This overcurrent and compound voltage blocking module resolves conflicts where fault currents fail to meet quick break settings during phase or three-phase short circuits. It introduces a composite voltage loop to reduce overcurrent thresholds. Tests include undervoltage or negative sequence voltage action values, current thresholds, and maximum sensitivity angles. The overcurrent angle module tests directional protection settings, checking both angles and magnitudes for overcurrent and zero sequence. Simply set the start and end values, choose a step size, and the system automatically scans through all test points. The reclosure module tests integrated protection systems, including overcurrent, distance, zero sequence and reclosure functions. It precisely controls fault closing angles, adds decaying DC components, and configures line voltage parameters for synchronization verification. Plus, it supports GPS synchronized testing across multiple terminals simultaneously. The slip frequency module can test the action value, action time, DF/DT value, undervoltage lockout value, and undercurrent lockout value of various frequency relays and underfrequency load shedding automatic devices. The slip voltage module can test the action value, action time, DF/DT value, and undercurrent lockout value of various voltage relays and underfrequency load shedding automatic devices. The optical power measurement function automatically measures and displays optical power information when the fiber is connected to the corresponding optical port. The interface shows the current transmit and receive power levels as well as the temperature of the optical port. Now let's look at the system settings interface. The KFA320 features a convenient auxiliary DC output function. Here's how it works. First, select either a preset amplitude or manually enter a desired value by checking the box next to the voltage display. Then simply click OK to activate the output. In the System Configuration module, users can select the output type for KFA320. When power amplitude is selected, the amplifier output is enabled, and the tester outputs analog voltage and current after running. When low level is selected, the low level output is enabled, and the tester outputs low level voltage and current after running. When IEC 61859-2 is selected, the tester outputs according to the IEC 61859-2 protocol. The SV and GOOSE configuration section allows us to easily set up the SV and GOOSE message, including the SV output, GOOSE subscriptions, and GOOSE publishing. We can edit the information here. All reports and parameters are stored in the device. In the File Management module, we can easily import settings from other devices, or export the report or parameters to other device whenever needed. The clock configuration function supports setting synchronization sources, including GPS, optical I or IGB, electrical I or IGB, time zone setting, and external trigger input and output types and methods, ensuring precise timing and flexible adaptation. The software configuration lets us set the tester's default ratings, including voltage, current and frequency values for single-phase operation. Just adjust your settings and click Apply to save. Next is the Common Settings section, where you can personalize our experience by adjusting the language, screen brightness, and other preferences to match our needs. The software upgrade feature allows us to easily update the device's firmware to the latest version. The battery section displays the battery information, showing remaining capacity and status.